Hello, welcome back to our lecture series on circuits and networks. So today we are doing some more problems in RL switching analysis. So before going to the depth of today's class, um, if some problems are there in your question paper on this aspect like this, where nothing is mentioned because you can see in this problem they are not telling you to do the analysis with S domain or with conventional time domain analysis. They are not commenting anything. Please read the question. Switch S is moved from 1 to 2 at t is equal to 0. Steady state have been established in position 1. Find V of t for t greater than 0. So they are not commending you to do any tool typically. They are not commending you to do this problem with S domain or to do the same problem with time domain analysis, because choice is yours. So personally, I will tell you to use S domain analysis, because in this problem, or not only in this problem, in the previous problem also, you please compare your work on S domain analysis and conventional solution method of differential equation solution method. Definitely S domain analysis will be more easier if you know the basics of Laplace transform. So I suggest you to be strong in the basics of Laplace transform, so that in second module and third module, in both the module, you will get a good upper hand to do problems in S domain. Okay. Normally in question papers, questions are coming like this only. They will not tell you to do S domain and all. In very few times we can see questions are there like solve using Laplace transform. But the other way, normally they will not ask you to solve questions using time domain analysis. It's your choice. Okay. So now today's problem, we can see it is asked to find voltage. In last question, you was asked to find current, but today it is voltage. How you can find voltage? So before going to that, you should have a basic knowledge that for current, for problems with current I of S, you are normally applying KVL in loops. But if voltage V of S is asked, generally, I am specifically speaking, generally, not always, generally, you have to apply nodal analysis. No mesh analysis or loop analysis is needed. Nodal analysis is preferred. Nodal analysis is preferred. Keep this thing in your mind. Nodal analysis is generally preferred for problems where V of t is asked, because nodal equations are written by taking voltage as the main parameter, and loop equation or mesh equations are written by taking current as the main parameter. Okay, so it's very simple doing such RL problem in S domain analysis. Not only RL, RC, RLC are very simple compared to time domain analysis. That's why we are doing S domain analysis just after time domain analysis. Okay, so let us start the problem. So this is the solution. Initially, what I am going to do is, I want to check the initial condition. I know switch was moved from 1 to 2 at t is equal to 0. So what about t is equal to 0 minus? Before that switching, this switch S, this is S. This switch S is connected to position 1. Is connected to position 1. This is position 1. So this was the only circuit. The other circuit was not connected initially. So that I am drawing this as an equivalent circuit at t is equal to 0 minus instant just before switching. T is equal to 0 minus. Okay, 2 voltage supply is there, a 2 ohm resistor is there, switch is there. Okay, switch is no need to indicate the switch because confusion may have S. As we are using S, you may get confused in S domain analysis. That's why no need to mention the switch. Please check here. I know there is an inductor, but how I can represent? Is it open circuit or short circuit? Generally, you are having the same doubt always. But keep this thing very consciously in your mind that if the circuit is in steady state, you have to represent the inductor with open circuit. Okay, if the circuit is not in steady state or the circuit is not carrying any current, you can represent that with open circuit also. But we know at this instant of switching to 2 at t is equal to 0, the inductor is carrying some initial current based on the position in 1 because it was connected at position 1 for a long time. From negative infinity it was connected to position 1 and they are staying, well, they are having the statement in the problem also. Steady state have been established. So steady state mean, what is the equation of steady state? Okay, if you are having still doubts, you can refer our last lecture. In that, I was explaining detailedly about the concept of inductor in open circuit. Sorry, steady state. Why inductor is open circuit or short circuit in steady state and transient period. So now I have to connect inductor with a short circuit as it is in steady state. And now I can write the current equation I0 minus is equal to voltage by resistance V by R, that is equal to 2 by 2, that is equal to 1 ampere. As I0 minus is equal to 1 ampere, I0 is equal to 1 ampere and I0 plus is also equal to 1 ampere because it is a inductor. Because it is a inductor. Inductor will not oppose sudden change in current. So now this instant represents before switching. Switch is in position 1. But this instant represents after switching. Switch is in position 2. You should be very careful. So at the initial time of switch in position 2, the inductor will carry the same current of 1 ampere. Okay, now we are going to move to the next case. Anyhow, initial current 1 ampere is already obtained. Now what is our aim? Now we want to represent the exact condition, that is switch is in position 2. In that condition we want to find V of t for t greater than 0. For that we have to draw the circuit diagram with switch in position 2 in S domain because we are directly applying S domain analysis in that case. Okay, let us move to that case. Okay, now we are on the important area of this problem, that is step 2. Now we are considering the circuit with switch is moved to position 2. Switch is in position 2. So, and we are also applying S domain analysis. We are not writing the differential equation and all. Directly we are writing S domain equation. So, special care should be given while marking the all components in S domain. Okay. So, here are some other things. Voltage source is there, some resistor is there, but we are not minding that side because switch is connected to position 2. In position 2, inductor is there, resistor is there, another inductor is there. And this is Vs, voltage in S domain. Initially it was V of t, now I am marking it as V of S. And it was 1 ohm resistor there. Okay. And this inductance value was 2 initially. But is it 2 now? No. Because an inductor, if L in time domain, it should be marked as Ls in frequency domain. And if there is initial current is there, we have to connect a battery with reverse polarity. And its value will be I0 into L. V0 is nothing but I0 into L. So in this example, inductor is 2. So we have to represent it as 2S. and its voltage source is, initial current I0 was 1 ampere. So 1 ampere into 2, it will be 2 volt. So I have to write 2S here, and here a battery should be connected in reverse polarity with 2 voltage. And we are having a 1 ohm inductor, an inductor with 1 Henry. So it should be written as 1 into S. Okay, now this is the time for applying. Nodal analysis. Why I am applying nodal analysis here? Because you are asked to find V of t. Voltage is needed. That's why nodal analysis is the better option. If voltage is needed, nodal analysis is the better option. For that, I am considering this as a node where more than 3 elements are meeting. And as this is Vs, voltage in S domain, this will be also Vs, this will be also Vs, this will be also Vs. Okay, all the parallel branches will be having a voltage of Vs. This will be also having Vs. V of S. Taking this as positive. All the V of S as positive because negative is the reference. It is here. So, I am writing current in all branches. For first branch, it is V of S minus 2 volt by inductance or impedance 2S. On second branch, it is plus V of S minus reference voltage is 0 by 1. For the third branch, it is V of S by V of S minus 0 is there, no need to write that. V of S by S, that is equal to 0. So, V of S minus 2 plus 2S into V of S plus 2 into all are V of S, 2 into V of S, that is equal to 0. So, V of S by 2S plus here it is a small mistake, it is not minus. If the battery is connected in reverse polarity, it is okay. Minus. If the battery is connected negative in the top side, we have to give plus. You can just apply a loop voltage equation, then you will get this V of S plus 2. So 2 by 2S plus Vs plus 2 V of S by 2S. So if V of S is taken common, it is V of S plus 2 Vs, 3 V of S by 2, 3 V of S by 2S. So it is this one and this one, 3 by 2S, okay, plus 1, that is equal to this term minus 1 by S. So V of S is equal to minus 1 by S divided by 1 plus 3 by 2S. So here also 2S. Is it okay? I will write in this side. So V of S will be minus 1 by S. Okay, this S and this S will get cancelled, and if you are writing the 2 in the top side in the numerator, we can write it as minus 2 by 2s plus 3, that is equal to minus 1 by s plus 1.5, that is v of s. So v of t is L inverse of v of s, that is equal to negative e raised to minus 1.5 t.